Hello, in this video I'm gonna make a crack surface pattern in any kinds of surface, especially in 3D. So let's try to make that. So let's start by creating a geometry first, and let's make some 3D surface that I'm gonna make a crack surface pattern on. So I guess I'll go with the sphere. Or I could also go with the meta ball to make it a bit more interesting. And okay, let's make a sphere and make a ISO offset this sphere and make a scatter point, and probably like 3 points like this, and copy this meta ball to this point using copy stamp. And let's make the meta ball a bit larger, like this. Yep. And can we set the weight a little bit bigger, like 3. Okay, let's try to make a surface like a crack pattern on this geometry. And now let's convert this into a mesh. Is it a mesh already? Not really sure. No. I think I have to convert this to a mesh. And the resolution is a bit too low. I think I have to make the resolution a bit high using U level a bit higher, like this. Yeah, this seems okay. Yeah, I think this is okay. Now let's go with this one. Now, first thing I would like to do is to I'm gonna use a loop, for loop for this one in order to make a crack. So the things that I'm gonna do is first make a really big big voronoi pattern on this surface, which will be the first iteration of making a crack. Then after making a voronoi cells, you have some fractures, like big fractures, voronoi fractures, and on each voronoi cells you do another voronoi until the voronoi cells becomes smaller or smaller than the minimum area that I'm gonna set as a parameter. So let's first pack this geometry, and I'm gonna apply a loop in order to make a voronoi. So I'm gonna use a for each primitives, and connect it here. And I also gotta make a create meta import node here so that I can use the detail attribute iterations. This one. Well, since I only have one pack geometry on the first time, it doesn't really matter, but it will matter once you have multiple geometries. Now, after going inside the loop, you first need to unpack this geometry, and then I need to get the total area of this packed geometry. So in order to do that, I am going to use a measure and use the area, so that you're gonna have a area parameter, area attributes on each primitive surface, on each surface, I mean the face of the mesh. Then what I want to do is to add all these areas for each faces, so that it will be a total area of this geometry. So what I could do, I could attach the attribute wrangle and change the run over to detail, and let's get all the primitives and get the total area. So this will be the total area. Initially it will be 0, and go look through all the primitives by using n primitives on 0 input, and increment the area by prim 0 area and at I position. Okay, and let's set the total area attributes for the detail to be this calculated area. Okay, let's check. Okay, now if I look at the geometry and do the detail, I have the total area as an attribute, so that's fine. Okay, and now at this point I'm gonna use this scatter to scatter the point on top of this surface, this unpacked surface. And what I'm gonna do as a trick, I am gonna set the force total count to be 4, fixed number as a 4, and also in each iterations I want to change the seed, the global seed of this point scattering. So what I'm gonna do, I am gonna use the value inside this for each begin metadata, which is in iterations. So I am gonna set the global seed using this iteration attributes. So I could make an expression calling detail attribute inside the, what was the name, for each begin one metadata 1, and the name of the attribute is iteration, and 0. And I could also multiply this by some big number like 234. Okay, and now by using this scatter point, I am going to make a voronoi fracture. First of all, the geometry to be fractured is the base geometry which is the impact geometry, this one. And I'm gonna use a scatter point, to scatter as a voronoi. And let's check the visuality. Yeah, it looks like this one. It's okay. This is the first step, the first iterations in order to make a voronoi. Let's increase the resolution a bit. Okay. Now it seems okay. Now, the thing with the voronoi, if I make like this, you have an inner geometry like the one like this one, but what I need is only the outside in order to use it as a crack surface. So I am gonna delete the inside geometry, which was created by the voronoi fracture. So I'm gonna use delete and set the group to delete to be inside. So by doing this, I don't have anything inside here. Okay, it's good. Now after this, I am going to pack this again. Now what's doing in this for each loop is that it's looking at all the packed geometry and doing iterations to make a voronoi. Now this for loop isn't enough in order to make another loop inside this newly created voronoi cell. So what I'm gonna do, I am gonna create another for loop. This time using a number for each number loop. And you start to control how many times you want to loop through this voronoi fracturing. Now the number is set to 10 as the default, but I want to make it as I want to make it controllable, so I'll make a null, name this controller, and set some parameters that I want to control. Okay, first of all is a maximum iteration, so I'm gonna name it max iter. Okay, apply, and set the range from, I guess, 1 to 10 is fine. Okay, apply, accept, let's set the 3 as a default, and copy this parameter and paste it to the iterations for each number node. Okay, now bring this top, the first part of the for loop number, to be top in between the pack and for each primitive, and connect the pack to here and connect the for each begin 2 to for each begin 1. Then bring this end loop to the far bottom and connect the for each end 1 to for end each 2. And now by doing this, I think I'm able to control. Oh, and one thing I also need to do right now, I'm setting the gather method to merge, but I'm gonna have to do the feedback each iterations. And let's check this one as well. This one's merge, each iteration is fine. Okay. And also this one, right now it says fetch input, but I'm gonna set to fetch feedback. Now it's making a iterative voronoi. Now inside the scatter, I'm only using the iterations for the first for each loop, but I also would like to use this one, the for each count 1 iterations as well. So let's add it. Let's copy this. Oops. Copy this and add, paste this. And this time the name is for each count 2. No, count 1. And multiply by a random number. Okay. Now if I increase this value, I should be seeing a multiple crack patterns on this surface, which I am not sure if I'm seeing it correctly. Let's see, pack. Think I am not seeing it correctly. Let's check. Okay, I think I'm doing wrong with this pack. I have to use the name attribute name to pack so that it will be it will pack as one cell of a voronoi cell. If I don't use this, I'm just using. Okay, now it seems to doing fine. Now the iteration seems a bit too high. I'm gonna set to 4. Okay. Now this itself seems okay. Doing what I am intended to do. But thing is that some part becomes bigger than some part. If you compare this crack surface with this one seems a bit bigger than this one, obviously, and I would like to control all the cracked surface to be this about the same size, preferably. Well, sometimes this might be good for some purposes, but for my purpose, I would like to make all the surface to be as much the same area as possible. So that's where you can use the total area that you made here. Now, what I can do is to give a switch here, and inside the switch I can make also make a switch with the original for each began input. This one. Let's reorder this like this. And now I can make some expression in this select input somehow using the total area. Now, the expression that I'm gonna use is, first of all, I also need some information like the minimum area, like how the minimum area that you want to set for each surface, for each crack surface, so that if the surface is less than minimum area, you don't want to make you don't want to split the surface to voronoi anymore. So that's where you use switch to go with the original or go with the voronoi fractured newly created crack surface. So let's make a new parameter for setting the minimum area. I'll call it min area. Okay. And apply. And inside the switch, I'm gonna set the expression detail total area total. Okay, where's the total area? This should be the total area. So the total area attribute of total area node divided by ch controller min area. Okay, and if this calculation is bigger than 1, then divide the voronoi. But if it's less than 1, then go with this original one. That's how you control the split. Now the minimum area is right now 0, so I would like to set something like, not really sure about the like 1. What about 0.1? Doesn't really. Okay, I have to look at this part. Now if I set to 1, you see that the cracked surface becomes bigger. Try to make all the surface to be close to the area of 1. If I set to 0.1, then everything is trying to make close to the area of 0.1. And this, even if you increase the number of iterations, if it's reach to 0.1, the area, if the area reaches to 0.1, then it doesn't make a fracture anymore. But if you make this minimum area a little bit smaller, and if you try to make the iterations smaller this as well, then you can see that you can continue to iterate until some part where the area of each cell reaches to 0.05. Now it doesn't seem to change anymore, just around this part. Yeah, that's how you can control the parameter at the crack surface areas. this. Okay, now this seems good. I'll go with the iteration 6 and minimum area of 0.05. Now that I got a area to use it as a cracked surface, let's try to visualize more like a cracked surface as a 3D cracked surface to make it more interesting. Now I'm gonna use another for each primitive to control each surface with the thickness, the depth, to make it 3D. Now I'm looking at each primitive right now, and first of all, since all the geometry that I'm going through is packed right now, so I'm gonna unpack this again. And what I can do, I can transform this and kind of uniform scale, which will make and also I need to set the pivot to be center of each geometry, so SEX, SEY, and SEZ. I mean CEZ, CEX, CEY, and CEZ. Okay. Am I seeing anything? I'm not sure. Yeah, somewhere. Pretty small. Okay, where is it? Okay, okay, here. So this is one part of the geometry that I'm looking at, and if I use this transform and make it smaller, the reason why I'm making this smaller is to kind of calculate the normal for making a offset of this surface, cracked surface, so that you can have some edges to be shown as edges between the cracked surface. I'll show you how. I'm gonna use the point wrangle to actually make a normal vector of each surface, and connect the first input with the unpacked geometry and the second one with the transform one, and set the normal to normalize 0.1 p num. Now what this means is that if you look at the node, the normal, well, there is some problem here because I'm calculating the normal from the center point 0, 0, 0, and some part like here doesn't have a good normal position. So okay, what I'm gonna do, I'm gonna use a normal node first to actually calculate for the points, and let's see how it looks like with this one. Okay, This one looks okay, good. Now, what I wanna try to make is that I would like to make each node, each normal of the on the surface to go a bit closer to direct a bit close to the center, so that I can use it to show a cracked edge. Now, in order to do that, I need to have the center point of this geometry, which I think I could get using the this get BB box center. I think I can use this function to get the center of this geometry. So what I can do, I will use the, first of all, I get the vector center using the get BB box center of the geometry on the input 0. Okay, now next, I'm not gonna use this one, but I'm gonna calculate the normal, calculate the vector from each point to go to the center point, which can be calculated by center minus point. I'm gonna normalize this, and probably I can multiply this with some parameter here, how much it should go to the center. So I'll name this edge edge strengths. Edge val. Okay, I'm just gonna call it edge val. Okay. And set the normal to, I'm gonna add normal with this value. And I don't need this anymore, so I'll delete this, delete the second input, and what else I need? Is it changing? I don't think so. Yeah, because I don't have this parameter. Now I click this to, okay, now it's working. Now I'm gonna add another parameter here so that I can control everything here, and I'm gonna name this edge val. Let's go from 0 to 1. And copy this parameter, paste it here. Okay. And connect it here. And if I look at this, yeah, every normal is facing a bit closer to the each face's center. Yeah, that's what I want. Now, after making a normal, setting a normal. I also would like to attach a resample. And this one is because I want to make this fracturing crack surface pattern to have some detail to its surface. So I'm gonna use the resample by polygon edge, and let's see the point. Right now, yeah, I think I can add some edge numbers controlling this length. Maybe I can make a parameter for this one as well. So surface detail, and from 0, maybe 0.01 to 0.1, copy and paste it here. All right, and make a fuse to actually merge weld all the connected points, and that's all for each. And now I have something like this one, looking like a patched surface. Maybe too much point right now. I can increase a little bit, something like this. Okay. And now, in order to make much more like a crack surface, since I don't really see like a crack surface right now, it's too straight. Each cell looks too straight right now, so in order to make it more like a crack surface, I'm gonna use a noise function to make it more like a natural form. I'm gonna use point wrangle. And let's give some parameter here as well. First of all, noise smoothness. And also noise strength. And let's make a vector called noise direction using the noise, using the seed with the point position plus the noise smoothness. And apply the new point position to be set fit noise direction with the from 0, 1 to apply from -1 to 1, and use that for use the same thing for Y and Z. So I'm just gonna copy paste it here and just change here to Z and Y. Okay. And also let's change the let's add a variable. Oops. I mean, let's add the attribute for each point to set the color of the point. Now, maybe I can use the color from the bottom to top to make it a bit interesting. So the point Y should go from somewhere around -3 to 3. So I'll set to fit to 0 to 1. And click this. Okay, and I'm noticing I'm not using noise strength here. I'm gonna multiply this vector direction, the noise direction, with the noise strength. Now I'll click this here to promote the parameter here, and let's try to change this to see if I see any changes. Yeah, I do see some changes here. If I change it to 10, maybe it's a bit too large. 5, probably 3. Yeah, it's getting closer. 5, yeah, 5 probably is good. 8, it's also good with the small noise strengths. 10, 20, probably good. Okay, so that's for that. I think I can also make a new parameter for the controllers to add some value here. Now first, a noise smoothness. From 0 to somewhere like 20. And noise strengths from 0 to 1. Okay. And copy this smoothness to here. And I'll just copy this, paste it here, and this one become noise strength. Yeah, it's too big. Yeah, something like this. Now, after this, I can poly extrude. To make it 3D. Now before doing that, now that I have those colors, I don't want to have it anymore, so I go to the voronoi and turn off this visualize pieces. Okay, and connect this poly extrude here, and here's the part that you can use a normal that you have set before. I can go to the point normal, use the existing to actually use the existing normal to calculate the extrusion. Now if I increase this, I'm having something interesting here. Okay, what's the problem with this? I look at the normal. Let me check. If I change the edge value, it doesn't, the normal doesn't seem to change. Now that's a problem. Why is that? Okay, using diffuse, it's somewhere, it's updating the point normal, so uncheck this. And now that it should be using the normal that I have set manually. Okay, now if I look at the poly extrude, yep, it's making an extrusion with the edge being by showing the edges like this. It's good. Now some color looks a bit off, like here. I think it's the problem with the normals. So after this, I could use the new normal. And doesn't really change. Yeah, since this is not a triangulated geometry, that's the problem. So what I can do here, after this, maybe I can do, maybe I can do a remesh. Something like this. Maybe I can set the lengths somewhere like this one. And maybe for this one I don't think I need a fuse, so let's connect directly to the pack. And let's go back to the bottom. Now it seems a bit better, I guess. If I set this to normal. Nope. What if I set the color? Yeah, still some part looks a bit off. That's because I'm moving a lot of points. Wait, I have something like this and dividing geometry like this, and yeah, something like this. Okay, maybe this one. Okay, I guess that was the problem with this resample. That's making a bit weird, but that's how you wanted to control the details. So what if I maybe I can use the divide after the resample. Yeah. Now I think you have what you want to have. If I remove this, connect it together. And if I increase the surface detail, which means if I decrease the surface detail value. Does it make any difference here? If with the probably, but not so much. Maybe I don't really need those. But it's better to have a triangulate divisions. Yeah, maybe I should have those as well. Okay. And let's go back here. Do I need a normal? Probably yes. Okay, then last of all, let's connect the color node to use an attribute called col to set the color from bottom to top. Let's hide the lines. Let's make it more brighter. Orangish. I'll bring this a bit to the right. This one to the left. Yeah, something like this. So procedurally you can create a 3D cracked surface like this. Now, and you can control the pattern. Oh, and also let's try to parameterize this distance of the extrusion as well. Let's make a depth of the crack, and range will be 0 to 1. Copy this parameter and paste it to here. Oop. Okay. Now it's too big. Now let's see how does those parameter work. Now the first one is the iteration of the crack. How many times you want to make a crack? Oh, so I want to make the detail a bit bigger to see the difference, so that you can see the difference. Okay, somewhere around here. And the minimum area is the minimum area of each surface crack. If I increase this one, you have bigger surface, bigger crack. If you have less, like 0.025, you have smaller cracks like these. Let's go with 3.5. And noise smoothness controls the noise of this cracked surface. If you make it to 0, it becomes straight cracking patterns. If you make this to the right, You can see the cracks go wild. And you can also control how much it should move each point should move with the noise function. You can use this noise strength. If you make it too big, it doesn't look like a crack anymore. So gotta use with the caution. Somewhere around here looks good. Yeah. Somewhere around here. And the depths is the depths of the crack. And also if you wanna keep the depths like this and keep the edges more thicker, you can control this edge value. If you decrease this, you have less edges. If you increase this, you have more edges to be shown. Yeah, that's about it. That's how you can create a procedural crack pattern by just using the SOP nodes. Okay, that's it. Thank you.